Hi everyone, I'm James. I'm the CTO over at Cynozure, and hopefully you're here to hear about building future-proof data platforms. You have to forgive me if I'm coughing and spluttering at all through this, as I've got a little cold at the moment. Um, Down the bottom or top on your screen, you should see some of the options like Q&A and chat. I've kind of got all of that open in front of me here, so I'd welcome questions throughout as we're going along. If you want me to clarify anything or go further into a point, then please do use that, and I'll keep an eye out and answer them. Also, if you have any troubles with my audio or anything like that at any point, good way to let me know in there. So jumping in quickly, for those of you who perhaps don't know Cynozure as well, let me just shoot through a bit of background on us. We're a people-led data and analytics strategy company. So we help organizations on that end-to-end journey of delivering their data capability. We do that across kind of four main areas: advise, which is our sort of typically data strategy work. We're going to talk a little bit about data strategy in today's session. Design and build, which is all about architecting and developing solutions, which is obviously part of the theme for today. Maximize is all about actually driving the business outcomes, whether that's through use cases or helping build teams and processes for the delivery of data. And grow is about coaching and supporting individuals and aspiring data leaders. We do that for a whole load of different companies, big and small. Part of the reason for kind of bringing this up at the start of the talk is not just to brag about all the amazing companies we work for, but to highlight that we really do get to work with the massive breadth of companies, and the kind of content and topics we're talking through today is a synthesis of everything we've learned about how everything from public sectors, charities, through to financial services, investment firms, and so on, of differing sizes from 1 million into hundreds, billions, how they all approach things in the different ways and different mindsets you can learn from them. And then outside of consulting as well, we run a chief data officer network with 300 plus members now, run regular events there. Our CEO runs a great podcast called Hub and Spoken. So if you enjoy the content today, that's worth checking out, and has some amazing guest speakers in on it. We partner with City Uni, particularly around their masters in data science and business intelligence, to shape that next generation of leaders. In fact, we're working with a PhD student now for the next 9 months on their thesis, which is going to be exciting. So, pouring intro bit over into what we're here to talk about today, which is building future-proof data platforms. I've done many versions of this webinar over the last few years, kind of constantly refreshing it and tweaking it. And what we're going to talk today, it's that future-proofing bit of it that's really important, and it's best framed by this next slide, which is the landscape at the moment is crazy, especially if you're new to it. If you've not built a platform, if you've not been doing this for years, you see pictures and slides like this, and I mean, you can see down the bottom, I popped the source in for this one. This is 3 years old. This has got bigger, it's got worse, it's got more complicated. And it's really difficult if you're trying to figure out, okay, I want to deliver some value from data. I know I need to do the technical bit of this. I need to create some kind of platform. Where should I start? What should I do? When you're overwhelmed with this kind of range of vendors, it's really difficult to penetrate. And that's made worse by the fact that so many of these will have a strap line along the lines of delivering analytics or zero to value in no time, or everything you need for data, when in reality, they're probably just dealing with one bit of the journey of the capability that you need to solve. So you take that horrible, complex landscape in terms of figuring out what's out there, and you couple that with the fact that it's constantly changing, and you have a real recipe for making it difficult to get started and difficult to know whether you're on the right track. So you might have seen versions of this chart before. There's just a really simple way of showing how, over the last, let's say, decade to 2 decades that this time span would probably cover, we've moved from on-premise relational databases like SQL servers and oracles. We've seen specialist data warehouse appliances start to come in to be high performance and deal with larger data sets. We got the explosion of Hadoop and big data, and there was a time when that was going to be the kind of future for everything. And And then suddenly cloud really became a hot topic, and organizations were starting to look at their cloud strategies and closing down their data centers. And then we kind of got into more modern and updated cloud offerings. SaaS solutions started to become incredibly popular, and a lot of new entries to market that had been enabled by the kind of primary cloud vendors like AWS and Azure. And who knows what's next to the right of that, because I don't know what's next to the right of that. I do know it's going to change. That's the only thing I can be certain of. Couple that with, it's not just the technology landscape that's changing, the complexity of what our businesses want to do and how they want to use data is also increasing as well. So, we're at a time of awareness of what data can do and can achieve that's greater than it has ever been before. I mean, a perfect example of this that I'm sure you're all talking about probably daily at the moment is stuff like ChatGPT. That has demonstrated, for all its flaws and failures, how sophisticated the use of data, the use of machine learning and so on can be in an organization, and the ability for it to be a absolutely game-changing capability. And we've had stories and organizations, the likes of Netflix and Facebook and Google and Amazon and Spotify and so on, that have all built their success in part around their ability to leverage and use their data in sophisticated and effective ways. So that's driving the demand for our own internal customers to do more with data, to get more with data, to be sophisticated, to find our machine learning use case in our organization. And that's only ever increasing. Basic reporting, dashboards, KPIs, etc., is now expected, and people want more than that. So we're playing catch up, or trying to stay one step ahead of the demands that our businesses in there. And that speed that things are changing, the pace in our organization, so we've got to keep up with, means it's really hard to ever build something perfectly, to know we're definitely doing the right thing, and to make sure that we are planning far enough ahead. We talk about the journey that people go through as something called the level up framework. This is a really simplified view of what we mean by that. This is based on observation and lived experience from all of our team members across hundreds of different customers and different organizations that we've all worked in, and talks about how you move through, early on establishing the agenda for data, creating that strategy, starting to get the buy-in, beginning to prove value, test some things out, maybe building early teams, early platforms, early use cases, into scaling out that capability across your organization, and onwards and upwards from there. And what you need at each of these points in the journey is different as well. The platform that you require when you're proving value is different from what you require when you're scaling, is different from what you will require when you are accelerating and optimizing, and so on. So you are constantly needing to think about evolving that. With all of those things in mind, it means that there is no perfect technology solution. There's nothing you can sit down and say, well, if you buy insert tech vendor's platform here, you're going to be set for life, you'll have no problems, it's going to work perfectly for you, and you'll never want to change. So for me, future-proofing our data platforms, future-proofing our technology strategy is as much about our mindsets and approach as it is to picking the right tools in the first place. And in this session, we're going to explore 5 kind of key mindsets that you can adopt when you are building your platforms and thinking about how you approach it, that will make sure you can evolve and iterate along with that changing context that we've just been discussing. So the first mindset is nothing to do with technology. It is about data strategy. So we define data strategy or break data strategy down, I should say, as these 6 pillars. So vision and value, where's the value from data coming from? For lots of organizations, where's the money coming from? But it might be about how you're going to manage risk, how you're going to improve society and the environment. However it is you define value, how is data going to contribute to that, and ultimately your wider business strategy? The people and culture, so the teams, the skills, and so on that you're going to create in your organization. The operating model, how you're going to run data, gather requirements, prioritize, deliver, support. your platform, technology and architecture. What route do you think you need to go down? Your governance, so how are you going to manage data in your organization, keep it safe, protect it, and make sure it's used effectively? And what's the plan to bring all of that together? The reason this is mindset number one, why I see it as so important, is that whenever anyone asks, why do we see projects fail? Why do we see data warehouse projects or data platform projects, or however you want to describe it, fail? The number one reason is because they are treated as technology projects and they are not treated as value driving initiatives that are aligned to a strategy and that are focused on outcomes. It's kind of all too common. And, if I just jump back for a second to that level up framework, lots of people, lots of organizations will jump straight into that scale phase with their data platform. And what we inevitably hear when they've done that is, I'm struggling to get the buy-in. I'm struggling to get the users on the platform. I can't find the use cases. I'm now struggling with investment that I need to make it work. And it's because it's been treated as just a purely technical problem statement. It hasn't been put in the context of the business, and it hasn't gone through those established stages to get the buy-in, to figure out the strategy. It hasn't gone through that prove value to show that there's genuine worth there. So important to make sure we're clear about vision, but also our strategy is going to help us think about what skills do we want to bring in? Are we looking to build teams in-house, or is this something we want to outsource? If we're building in-house, how big can our team be? What kind of roles might I want to be investing in? And how might that inform the kind of tools and technologies I should pick, for example? How important is the governance and management and security side of it? Do I need to be picking tools that have absolutely the top security credentials because I live and work in a world where I'm highly regulated, I work with highly sensitive data, and security and management is king? Or am I in a place where, well, obviously I need a level of good security, I'm okay when it comes to overdoing that, I just need it to be decent, I don't need to overly invest in that? The one bit of this strategy that, if you're starting out and you're thinking about your platform, and that we will do as part of any technical architecture exercise, even if that's a standalone piece that we've been brought in, is the vision and value piece, and specifically use cases. So use cases are specific big business outcomes you're aiming towards, tied in with how you're going to use data to achieve that. So, really basic example might be like, I'm trying to improve my marketing campaign ROI by targeting my customers with more relevant content based on their past purchasing behaviors. It's a very sort of basic, simple kind of example of a use case. Understanding those is really, really important to building the right kind of platform, setting yourself on the right kind of journey, sequencing your tools and technologies, and when you're going to bring them in as well. Because if you don't know what your use cases are, then you can't pick the right technology. You might get lucky, you might make some good, solid choices because you're working at sort of reference architectures and fairly industry standard things, but they may still not be right for what you need. There's a big difference between your use cases all being about building some basic reporting and insight for people versus needing to enable real-time machine learning workloads for your platform. So understanding those use cases is going to help make the right choices, but it's also going to help you prioritize. So you understand which use cases are coming first, and then you can pick the right tools and parts of the platform to invest in first, because you can't do this all at once. You can't magically spring up a platform fully formed overnight, sadly. It takes time, no matter what many of the technology vendors may promise. And as we talked about, if we don't focus on the value piece, if we're unable to tie what we're doing in delivery back to our business value, then our platform is going to fail. It won't get the buy-in. It will just be a cost line in your business. So mindset number one is all about making sure that you've got a clear strategy to align any technical activity that you're doing towards. I like to have some specific takeaways for people from these kind of sessions. So at the end of each mindset, I've got an action you can take if you want to follow up on. So in this case, it's review your data strategy and identify if you've got a clear view of your use cases and the plan to deliver them. if you're going, I don't have a use case, sorry, I don't have a data strategy, that is probably the first thing to consider, is whether or not you need to go and create a full-fledged strategy. Clearly, you've got a gap there in terms of what direction are you going with data in your organization. So look at that, make sure you clear. What are you doing? What business problems are you trying to solve? How do we need to solve them? And what's the plan to deliver them? So mindset number 2 then. This is a big topic. I do a whole another webinar just on DataOps, so I've condensed down the kind of key points for this bit here. But DataOps is a great way to approach thinking about how you do delivery. And with anything, everything I talk about here today, and just generally anything that the industry talks about when it comes to standards and approaches and frameworks, you've got to make this pragmatic and you've got to make it work for you. So pick the best bits, pick the stuff that you think you can actually implement and that will make a difference, and make it your own. So what is DataOps? It is an approach to shipping high quality data products at pace. And there's 3 things I want you to take away from that sentence. First one's high quality, second one's data products, and third one's pace. So high quality, DataOps is all about quality. It's all about making sure that what comes out of our pipelines, of our platforms, of our tools can be trusted, can be used properly in there. A lot of the thinking behind DataOps is born out of lean manufacturing and that kind of industrial world. So easiest way to think about it is literally in a factory. You've got a pipeline. I've got a customer that manufactures metal ingots. If they get a quality problem at the end of that, it will cost anywhere in the region of $100,000 to $300,000 in lost time, lost materials, and waste, basically. So for them, detecting quality problems early is massively important, because there's really negative impacts. And DataOps borrows that exact mindset. How do we make sure everything we do in our platform is high quality and trusted? Because much like in a relationship, when you lose trust of your data, trust is very hard to regain and rebuild. It's much, much easier to lose. So how do we make sure that people can trust what we're doing in our platform? Makes them keep coming back. Data products then. So data products, again, a big topic on its own as well. The reason to think about data as a product here is that products outlive the technology that enables them. So by thinking about products, we can actually align ourselves much better to the business. We don't tie what we're doing with our platform completely tightly coupled to the tools and techniques that we are actually leveraging to enable it to happen. Data products are also, products have customers, they serve a purpose, they provide some value. So again, it starts to drive you into that value mindset. And pace, the third thing that DataOps is obsessed with, is speed of delivery. So how do we not only deliver it at high quality, but how do we deliver it fast? How do we automate and speed up what we're doing? And there's three main things that you can put in place to do this. Then these are the kind of foundational capabilities that you would need to establish as part of DataOps. So the first one is modern software engineering approaches, and we'll dig slightly more into that one on the next slide. But this is all about the tools that help you effectively manage your platform and have an effective software development lifecycle. All about automation. Pretty much everything in there is how can you automate and speed up what we're doing, whether that is automating releases of code, whether that's automating testing, whether that's managing your source control and enabling better collaboration, whether that is better detection of problems proactively and preemptively, and so forth. So like many things in the data world, it has that software engineering aspect has its roots in DevOps, in standard IT practices, but there are some differences that are born over to it. The second is agile delivery methodology. So the reason agile is important to DataOps is not the general methodology per se, but it's what that methodology is in theory there to enable, which is constant iteration. So small, minor, incremental improvements to what you're doing, releasing little and often, adding value regularly to your end customers, and measuring everything you do, both measuring your technology and platform and quality and performance of it, but also measuring your team and the work that you're doing, so you can understand how well am I performing and where can I improve? Where are the gaps? You know, are we really bad at estimating and therefore we are not planning well? Do we release a lot of code that has bugs and defects in it? Maybe we should invest in better testing processes, better release processes. All those kind of things will help then understand and hone and improve where your quality of your delivery is, and also make you faster because you make less mistakes. And the last one then, value focused cross-functional teams. So for me, this is particularly relevant in large organizations. So if you're in a big company, then this is much harder to do typically because of the way the organizational structures in those kinds of companies have evolved over many, many years. This tends to be more naturally how smaller and more nimble organizations might work. But it's about bringing together all the skills you need to deliver something, with the something being a clear end-to-end valuable output for the business. So if we think how a traditional organization might work, I might have a team of engineers, a team of analysts, a team of testers, a team of infrastructure people, and that team is only focused on delivering their bit of it. The engineers only care about getting the data in from the source system into the lake. The analysts only care about building the dashboard. The testers only care about making sure that they've run their tests. Nobody is focused on getting the value out, getting the end product to the customer in use, successful, changing the business. So this is all about bringing together your teams in a different way. And it starts to get people then to focus on the right stuff, which is outcomes, instead of their specific part of the world and how they happen to be contributing to that outcome. The tech space here covers quite a few things, think like full end-to-end lifecycle, proof of concepts, development, running. So across all of these things, there is multiple bits that you can put in place. This would cost way too much to try and do all of these things. So back to that kind of measuring piece that we were talking about in Agile, that's how one of the ways that you can prioritize what you're doing. You know, fail at testing a lot, look at automating your testing. Takes ages to get something into the production environment. Figure out if you can use automation, CI/CD, automated releasing to deliver that. You're constantly having problems and issues with your pipelines, but you don't find out till a user rings up. Look at your operations and your management and monitoring of what's going in your platform, the alerting to tell you what's happening. That's the kind of way to approach bringing in DataOps tooling. If you think back to that level up framework I was showing earlier, I often talk about DataOps being something that you may more heavily invest in at that accelerate stage, where you have proven that you've built a great platform, you've got a lot of stuff going, and actually you want to start getting into a place where you can deliver faster and quicker on the business, and you have the buy-in to go and invest in these kind of tools. So takeaway from this bit, look at your end-to-end development cycle, however you approach it, but think about how you get requirements, design solution, build them, test them, release them, support them, whatever the way you classify that cycle, and think about where are the biggest blockers in your end-to-end life cycle. So like I was just talking about, does it take you ages to get something into production once it's built? And think about then, what tooling and automation could you use to fix that, close that gap, speed it up and get faster, get the pace quicker. Because if you can iterate quickly, if you can make changes when you need to, it's going to be much easier to make sure that your platform is keeping up with the business, it's evolving and is going to last longer and doesn't start to be seen as a legacy solution that needs changing. Cool. Mindset number 3 then is all about capabilities. So whenever I do an exercise with customers think about a platform, I like to get them thinking about what capabilities that they need in their platform. So by capabilities, I mean the kinds of things that you are seeing on screen now. It's not an exhaustive list, and I position these in different ways and at different levels depending on who my audience is and what I'm trying to talk to. But you might want to take a screenshot of those if you're following along with the little actions that you can take, because this is something you could use as part of the one coming up for this section. But the point of thinking in capabilities is it gets you focused on what you're trying to achieve with your platform. Not that you want to go and buy Snowflake or Redshift or SQL Server or Synapse or whatever it is. Not that you want Fivetran or Stitch or Rivery or what have you. It gets you thinking about, okay, I need to do batch ingestion of data. I've got some databases I need to do daily pulls in. I am going to need to do master data management in my platform. So I'm going to have to think about that tool. I do need to look at how I'm going to do machine learning because I do have that requirement. I've got the use cases that merit the need for that. And by thinking in capabilities, you can make it then easier to go and navigate that horrible tech landscape that we were talking about at the start, because instead of coming in and thinking about, oh, how does this piece of technology fit into the mix of what I'm trying to do, you've started by thinking about, what am I trying to do? I need to manage my data quality. Okay, I understand beyond just the depth of I need to manage my data quality. I need to define rules. I want the rules to be able to run and execute across not just my data platform, but all my business systems. I'd like visualizations in there. I'd like workflow management for remediation of data quality. I'd like alerting to know when it happens. I'd like it to integrate with my data catalog so that when people browse what we've got, they can see what the quality score is. Now you understand that that's how you want data quality to work in your platform. Now you can approach the marketplace and start to think about, well, who can fill that need? Who has the kind of tooling and solutions that would enable those things to happen? And it might not even be a data quality tool set. If you understood what you wanted to do, you might decide, actually, quite happy that I could define that all as some SQL queries and a Power BI dashboard, and that deals with everything I want to do in that space, so I'm not going to invest there. So these capabilities, they should be absolute technology agnostic. They should get you thinking about specifically what it is you want to do, what it is you want to be able to achieve with your platform when you get there, where your priorities are, and then you can go and translate that into the tech, the solutions, and what you want to do that. The priorities bit on this is going to largely be driven by use cases. So what am I trying to deliver first, and what is needed in order to make that possible to deliver. But there's also going to be some non-negotiable parts of your platform, if you like, that you've got to have some kind of storage. I would say in any platform, you're going to need a way of getting data into the platform. You're going to need some way of presenting it and consuming it. You're going to need some way of processing it and transforming it. So there are some parts of a stack that are kind of inevitable as a starting point. But exactly what kind you need, that comes from those use cases, that comes from thinking about the capabilities, and that will help lead you towards the right choices in the market. So in terms of the sort of thing that you can do with this, if you've got an existing data platform, go think about, well, what do I have in place now? What capabilities do I have? And how do I score on those? Rank them. Am I like really good at batch ingestion? I'm red on real-time ingestion. I've got no capability for it, and so on and so forth, until you can get a view on how well you think you're covered. Are there any gaps that you're going, actually, I now recognize that part of the reason we're failing is because we haven't thought about this capability and it's causing me a lot of pain day to day? Or are you in a really good place and you've highlighted areas of potential future expansion? Right, number 4 then on our mindsets is modularity. So thinking back to our evolving pictures from the start, that things are always changing, recognizing that we can't just have everything immediately, that platforms take years realistically to develop to a point of maturity and are constantly evolving, we need to think about building modular capabilities. Lego is somewhat of an overused analogy in this space, but it's just a really good one for describing what we're talking about here. So if we start to think about our data platform like a collection of Lego bricks, one Lego brick is not very interesting and you can't do very much with it. So you need multiple Lego bricks together to create something useful. You can get them in lots of different shapes, sizes, and colors, and you can get them in lots of different prices as well. So I can buy very expensive Lego kits or very cheap Lego kits. Many of them can be put together in the same kind of way, but some will be better than others. They all, in theory, click together nicely. And in fact, if I've got Lego that doesn't click together, it's not very useful, much like my data platform wouldn't be if I can't connect my various components together. And I can always buy more Lego. They get dirty, they get broken, they are no longer any good for whatever reason. I can go and buy more and I can add on and I can change and evolve my Lego model, my data platform over time. The key mindset here, and I will caveat this by saying this isn't necessarily true for everyone. So it's a decision that you need to make about yourself. But the key mindset here that I would say is probably true for most organizations is you should avoid building monolithic solutions. If you build monolithic solutions, it means any one part of it breaks and the whole thing needs replacing. Whereas we want to be in a place with our platforms, given we're trying to build future-proof platforms, that we can say, we don't like our reporting tool anymore. It's not serving the purpose. We can take it out and we can put something new in and we don't have to break anything else. My database is no longer performant enough and it can't scale to the volumes of data I'm having to deal with. That's okay. I can either replace it or maybe I can add on something new that deals with those types of data and that higher volume stuff. So we want to be able to swap and change parts of our platform over time so that one single bit doesn't become the Achilles heel for the entire platform, forcing us to replace. As I say, the caveat to that is maybe if you're in a smaller organization, a charity or a startup, sometimes monolithic solutions can be quite good because it can be very simple for you to procure, simpler for you to manage if you don't have lots of those skills, and can potentially provide a kind of quite cost-effective point for you. So you do need to apply this pragmatically to your organization. One of the other things to think about when it comes to building modular solutions is some of you might be familiar with Conway's law. So Conway's law says any organization that designs a system will inevitably produce a design whose structure is a copy of the organization's communication structure. So it's quite a wordy mouthful and it's worth having a quick read up on afterwards. But essentially what it's saying is if you build big monolithic teams and monolithic communication structures, you will create monolithic platforms. If you build diverse distributed teams, you'll build distributed and separate platforms and so on. You can see that kind of thing. Think microservices that came out of the IT world. Well, lots of software engineering teams are very much organized into pods. You've got mobile, front end, API, security, etc., etc., etc. Microservices mirrors that. Here's the front end microservices, the API microservices, so on. So you should think carefully about your team, how you're structured, how your organization is structured, because that will impact the kind of platform you inevitably drift towards creating. To bring this example to life, I've got a really sort of basic example of Azure that I'm probably well overdue to refresh some of the logos in here now. So I've aligned the next few slides to my level up framework that I was talking to. So proving value is my first stage. Imagine in our imaginary company here, we're starting out, I've just finished my data strategy, brilliant. My board loved it. I've got some investment and they've said, okay, prove that you can make something worthwhile. So I'm going to build my my first bit of platform, and the initial use case that I'm going to solve and go after is I'm just going to build a KPI dashboard for the business because we don't know how we're performing. So that's where I'm going to start. So it's pretty straightforward. I'm going to use a bit of Azure Data Factory to ingest my data from the database or whatever I've got as a source. I'm going to store that in Azure Data Lake Storage as a bit of a data lake type approach. I'm going to use Azure Data Factory again to process that and manage the transformations. And I don't have big data sets. I don't have complicated data sets. So I'm just going to use a SQL Server managed instance. Power BI is my visualization tool. Great. Some people in the business were already using that. And I can come in and I can write some SQL through SQL Operations Studio. Maybe I'm putting in a little bit of what is now Purview, but a data cataloging kind of capability. And I'm not doing much else. I'm just using the Azure portal to manage the platform. Brilliant. Nice, simple, easy setup in Azure. And my proof value stage goes well. So I start to need to expand again to the scale stage. More people across the business are coming to me and wanting to have their own dashboards and their own insights. And there's some more complicated questions coming in. There's some more data that we get in. So I can still work with my same ingestion setup. It's still batch sources, but volumes of data are getting a bit bigger. So I'm going to bring in Synapse Analytics, which is a more distributed storage engine, and add that to my stack as another option for storing and presenting data. We've hired some data scientists in the organization, so I'm going to add in a data science VM to give them an environment to work within that means they can experiment and test things out a little bit more. And I'm bringing in Azure DevOps at the bottom there in governance to bring in some of those DataOps principles, because actually I wasn't doing source control, I wasn't doing really release management. So we're going to start bringing that in and getting a little bit better at what we do. I haven't changed any of my existing stack here. I'm still using ADF, I'm still using my data lake, I'm still using my catalog, my Power BI, and so on. Take us further on, and I'm into my accelerating stage. It's been going well. I'm a few years down the line, and we're now a much more sophisticated organization when it comes to our use of data. I've got some real-time sources now because we've got the website hooked up to it, and I want to be taking real-time action on user journeys on the website. So I brought in Azure Event Hubs to manage my streaming. I've got much more complex workloads to process. So I've added Azure Databricks in, which can deal with some machine learning workloads, and it can deal with some streaming processing. I've got Azure Cosmos DB because I need a different type of data store to present data faster. I've got cognitive services to use some of the out-of-the-box AI offerings from Microsoft that we want to try and solve. And again, I've just layered on new tooling. I might even make the decision to swap some things out here. I might say I'm retiring my SQL managed instance because that no longer is needed and serves a purpose, and I'm moving what was in there into Synapse. I may even decide I'm going to adopt a lakehouse architecture and ditch Synapse and invest into Databricks. But the fact is, I have a modular approach to my platform where capabilities are clearly defined in terms of what each of these services are doing, and I can swap them out and I can change them at will. So I could keep evolving this for a long time without breaking it, and I can keep it fresh, and I can make sure I'm still leveraging the right tools in the market for me. So looking at our kind of what can you go and do today, have a look at your platform and think about, if I had to replace, insert component, if I had to bring in a new ETL tool or a new database or a new visualization tool set, what would happen? Would it completely break everything you're doing and force you to fully re-architect and redesign the solution, just a cascade off it? Or is it quite straightforward that you could swap something in, something out to make the change that you wanted to make? That will help you get a bit of a grip on how modular is what you've designed, or is everything very tightly coupled together that you can't change one thing without changing everything else? So our last mindset is about simplicity. Simplicity is an often overlooked and underappreciated value when it comes to building a data platform. I think we're all guilty in the technology space of liking complexity at times, liking to do sophisticated and clever things, but actually keeping it simple is the best thing that you can do for a platform if you want it to have a long-term future and health. It means less code, keep your code, your transformation as simple as you can to achieve the job. Use as few technology and components as you can to achieve the outcomes you need to achieve. Create less steps in your processes wherever possible. Try and make it as simple end to end, because then it'll be easier to build new things. It will be easier to change stuff when it breaks. It will be, or change stuff when you need to evolve it. It'll be easier to support it when it breaks, and be easier to hand it over to new team members. And you won't get to a place where you are buried in tens and thousands of lines of legacy code. Nobody understands components that you're not sure what would happen if you switch it off because it's been there so long. Keeping it simple is just something absolute to keep in mind from day one. I always like the quote, I'm sure probably you've heard before, of a designer knows he has achieved perfection, not when there is nothing left to add, but when there is nothing left to take away. Just apply that to your data platforms. Keeping that side simple, the one kind of practical tool and technique that can help you do this is a framework we call Lab to Factory. So the idea of Lab to Factory is having designated environments where you can experiment, where you allow freedom and flexibility. Maybe that's about trying new code and new tools and new algorithms. Maybe it's working with a new bit of data, whatever, where the teams that are doing that work, often analysts, data scientists, maybe people in lines of business, are the ones largely responsible for the governance and management of there. It's a place where you can test ideas out. Not every data idea is a good idea. Not every one yields results that are actually useful in the end. So getting those out of your system in a lab environment and finding they don't work helps you keep your production environment simple, because you're not productionizing workloads that ultimately nobody wants to use because they don't deliver something. So that's the factory side of it, though. That's our, if you like, where you might think of production. It's the bit that's properly managed, properly tested. It's got the support wrap around it how you need. Typically, it's sort of centrally controlled, but obviously whether maybe you're taking a data mesh approach and it's fully distributed domains and platforms or what have you, but there's a team responsible for looking after, maintaining and caring for it. There are defined tools. We might try something out in R in the lab, but we say it has to be recoded into Python if you want it deployed into production, because that's what we support and that's what we maintain. And we don't want multiple code standards in our production environment when one can meet the needs. So that factory environment, absolutely all about making sure that we've got a clear, nice, clean production environment that only has stuff put into it that has value and has merit. So in terms of what you could do today, you can go look at your data platform, look at the tools, the components, look at the jobs, the pipelines, the tables, how many dim customer new to do you have within your database that you never went back and cleaned up. Look at all of that and think about what could you remove from that? What could you switch off? Which reports could turn off? Which tables, which jobs, which servers, which components entirely could you remove that would have no meaningful impact on what you were doing, what you were delivering, or how you were delivering it? And then go turn them off, because why are they on if you don't need them? So that brings us to the end of the session. So just to kind of recap what we've talked about here. This is all about building future-proof platforms by adopting mindsets that are going to help us evolve as the complex industry around us, as our businesses and our user needs, as our data and so on changes around us as well. We're going to have a data strategy, because that's going to make sure everything we do in the technology space is pinned back and clearly aligned to value and use cases. And those use cases will help us prioritize and help us make the right decisions about what tools we need. We're going to leverage DataOps methods in order to deliver high quality data products at pace, looking at bringing in agile methodologies, looking at implementing the right tooling that can help us automate our workloads, and looking at making sure our teams are organized around value and delivery and not isolated silos of capability. speaking of capability, we're going to think in terms of capabilities. So we're not going to start from a technology, I need a database starting point. We're going to think about, what does my platform need to be able to deliver for me? And then we're going to approach the market and think about what's the best tool sets and technologies out there that meet those needs. We're going to build modular solutions so that we don't end up in a place where we have created a monolith and one thing changes and we have to throw it all away and go back to the drawing board. We're going to build in a way that lets us scale and add and remove over time when it comes to our platform. And finally, we're going to try and keep everything as simple as we can, minimizing the steps, the code, the tools, you name it, within our platform, because that's going to make it easy to manage. It's going to make it easy to maintain, and it's going to make it easier to change over time and keep pace with the business. And we can use a lab and factory mindset to help keep our production environment as clean as possible when it comes to the data sets, the pipelines, and use cases that we're delivering in there. So that takes us to the end of the webinar. I hope that has been useful. I will stick around for a couple of minutes in here if anyone wants to ask anything in the chat or the Q&A. But if I don't see anything in the next sort of 30 seconds or a minute, I'll close down the session. So brilliant. Thank you very much for your time. If anything we've talked about today is interesting, or you'd like a follow-up conversation, you can drop Justin, whose email is at the bottom there, a note, or you can reach out to me. I'm just james@cynozure.co.uk, or you can find me on LinkedIn. But yeah, thank you very much for coming along, and enjoy the rest of your days.